Hello guys, in the previous video that I did, I discussed color addition. But in this lesson, we're going to look at color subtraction using filters. Now, there are lots of cases of color subtraction, and one of it is in the use of filter or color filters, if you like. Now, in color subtraction, out of all of the colors that get to the filter, you get to see only an allowed color, okay, that gets out of the filter. For instance, you have a white light, which is a combination of all the 7 colors, that is the red, orange, yellow, blue, indigo, violet. Hits on the red filter, and then only the red light is allowed to pass through. Okay, that's how a color filter behaves. It allows color of a certain wavelength to pass through. Okay, so if it's a red filter, it allows colors of wavelength related to to red color. Okay, in other words, a red filter will only permit red light to pass through it. Now, a magenta filter, remember, we see this filter as magenta because 2 colors actually reflect to our eyes, that is red and blue colors. So a magenta filter will permit red and blue colors, or simply magenta, to pass through it. Remember, the combination of red and blue is magenta, right? So it will simply permit a magenta or a purple color to pass through it. Now, using filter of primary colors, filters absorb some colors of white light and let other colors through to create colored light. Now, if I use a red filter, only red will pass through. If I use a blue filter, only blue gets to pass through. Blue light gets to pass through. And if I use a green filter, only green light gets to pass through it. Okay, so basically filters of primary colors only allow the primary colors to pass through it that is related to that filter. Okay, using filter of secondary colors, for a magenta filter, we get to see the 2 colors that are actually reflected by the magenta color. Okay, the 2 colors, that is red and blue, we pass through it. For a cyan filter, we have green and blue colors passing through easily. Okay, now the reason is this: we see this as cyan because 2 colors are given off from it or are reflected from it. Okay, so it will only allow colors related to the same wavelength that are reflected to pass through. For a yellow filter, a red and a green light will pass through it easily. Now, investigating filters, color of filter and color that could be seen. So for a red filter, only a red light will be seen. A green filter, only a green light, only green light. For a blue filter, only blue. And then for a cyan filter, the colors that could be seen that can pass through it is blue and green, or in other words, cyan color can be seen. That is the same thing for magenta and then for yellow. Seeing colors in colored clothes. Now you have a colored clothes, this, and then if you observe a colored clothes from a white light, from a white light, you get to see the same color. Okay, so a blue will appear to be blue in a white light, red will appear to be red, green will appear to be green. But if you look at this same color on a red light, every other color will be absorbed red will be absorbed by any other part of the shirt that is not red, meaning that the blue trouser is going to absorb the red and appear to be black, and then the green stripe in the shirt will absorb the red and appear to be black, but then the red stripe will still reflect the red. Okay, now let's look at the blue light. What happens? Okay, before we look at what happened, what's our prediction? Let's predict. We are predicting that the blue trouser will appear to be blue because it's going to reflect blue light, and then these ones, every other color here, colored shirt, the green stripe and the red stripe, will appear to be black because they are going to absorb the blue. Let's see. Correct, that's good. So every other color here absorbs the blue. In that way we see this as black, but the blue trouser reflects the blue light. Okay, so for the yellow light, remember yellow is a combination of two colors. It's a combination of two colored lights, red and green colored light. So we expect the green here to appear green in a yellow light, the blue here to appear black, so it's going to absorb, it's actually reflecting blue, and we expect the red here to appear red because it's a component color of yellow. Okay, and that is it. So the blue trouser here appear black because it absorbs yellow and reflects nothing. Okay, now for the cyan is a combination of blue and green, so we expect the blue and green to remain the same, but then the red stripe here to be black, since it's going to absorb the cyan, it's going to reflect nothing. Okay, and that is it. The green remains the same, the green stripe, the blue remains the same, but the red absorbs the cyan. Okay, so notice that red that is reflected by the shirt is not a component color found in cyan. Okay, all right guys, that is it for today's lesson. I hope you enjoyed it. If you enjoy it and you like the lesson, don't forget to like the video and click on the subscribe button to subscribe to my channel for more videos like this. Thank you.